Okay, let's look at some examples of solving these. So here they're giving you an example of a simultaneous equation: 3x minus y is equal to 5, 2x plus y is equal to 5. Question A says, write in the form ax equal b. Hence, solve to find the values of x and y. Right, so your first step is to answer A. And in writing it in the form ax equal b is more or less writing it as a matrix. All right? So remember we says the A will be that 2 by 2 matrix with all the coefficients. The matrix Y, X will be the 2 by 1 matrix with the variables, and the matrix B will be the 2 by 1 matrix with the solution. So that is what it's going to look like. So we pull out the first coefficient, which is 3, we write it here. We pull up the second coefficient in that same equation, and we're not seeing any number here, so remember we said that there's a coefficient of 1. In this case it's -1. Below here we are going to write 2, and across here we're going to write +1. So this is a 2 by 2 matrix, which we represented by A as in our last video. And what we put here will be the letters in the question, and the letters in the question are x and y. And the matrix B, so this is matrix X, and the matrix B will be the solution. In this case, it is 5 and 5. So that's all what is required for A. So you're asked to write the matrix, the equation, the simultaneous equation in matrix format. So equation A will have a 2 by 2 matrix, which will be the coefficients of the simultaneous equation. So 3 and -1 came from the first equation, and 2 and 1 came from the second equation. X and y is placed there, and the solutions are placed there. All right, so let me just skip to the next one and I'll come back to this. So let's write this one as in matrix equation. So that's another one. So the A part of the answer, I want you to write it as a matrix equation. And the matrix equation is AX is equal to B. Okay, so let's try that. So what will be the A? The A will be the coefficients. What will be the X? The X will be the variables. And what will be the B? The B will be the solution in the question. So this is the question we're working with. And we go across. So the coefficient of the first one is 3, so you write it here. The coefficient of the second one is 4, so you write it here. The variables that we are dealing with will be x and y. The solution of the first will be 5, so you write it here. You move to the second part. Remember, if a letter is written without any number in front of it, the coefficient is 1. Here we're going to put 2, and the solution here is 1. All right, you can pause the video here and create your matrix equation to answer question 1. All right, for your question 1, it should look like this. Your 2 by 2 matrix. So 2, 1, 1, -2. If you had that, give yourself a mark. In this question again, we're still using x and y, and our solution will be 7 and 6. Right? Very simple. All right, for in the past, I've seen this particular part of the question given is given 1 mark. So that's the first skill you have to learn how to do, to transform from simultaneous equation to matrix method. All right, our next step now is to solve. And this is where this comes in. So we are basically going to try to find x, and x in this case will be um, the xy. All right, so we're going to be finding x, which is equal to a inverse times b. Okay, and what is the a? This is the a. So we need to find the inverse of a, and then we're going to multiply it by b, and that will give us our x and y. So I will advise students to write their x and y here, equal, do this part in your side work. So you're going to find a inverse in your side work. And remember, a inverse is equal to 1 over the determinant of a times the adjoint of a, as not of video. So what is the determinant? So you're going to take the 2 by 2 matrix. So it's going to be 3 times 1, multiplying all leading diagonals, minus 2 times negative 1. Okay, so 3 times 1 is 3, minus 2 times negative 1 is minus 2. So this is going to give us, remember when we have two minuses come in after each other, you can rewrite it as a plus, as a plus. So our determinant, which we are finding here, will give us 5. And then we are supposed to find the adjoint matrix of this. So the adjoint matrix will look like this. We swap the leading diagonals and we change the signs of our non-leading diagonal. So find the inverse in your side work and then you return it to the actual question. So this is the adjoint of A, and this was the determinant of A. So according to this, we need to write the A inverse, which is 1 over the determinant of A, and we found our determinant of A to be 5. And next to it, we are going to write the adjoint, which is 1, 1, 2, 3. Next to that, we are going to write our B, because that's what the formula says. Okay? Our next move is to multiply this 2 by 2 matrix by this 2 by 1 matrix to get a single matrix, okay? So it means therefore I'm going to write back everything that I'm not going to be using, which is the x and the y. I'm going to write back this 1 over 5, and I'm going to be solving these two matrices by multiplying them. So 1 times 5 plus 1 times 5 plus 1 times 5. Okay, remember it is row by column. Then we have 2 times 5 plus 3 times 5. If you get the skill, review it in our previous lessons. Alright, so next step now is to simplify that. So this will give us 5 plus 5, which is equal to 10. This will be 2 times 5 is 10, plus 15 is going to give us 25. All right? And our last line is to take our scalar matrix, the denominator of our scalar matrix, and we are going to put it under each of our elements in that matrix. So this will be 10 over this 5, which is our scalar, and 25 over this 5, which is our scalar. So it means therefore 10 divided by 5 is 2, and 25 divided by 5 is 5. Okay, and that is how we solve this. It's not hard at all. A little long, but it's not hard. All right, and we're using our equal matrix help here. We tell you that once two matrices are aligned, the corresponding elements are equal. Hence, so this will be a last statement for this question. Hence, because x is the first one listed and 2 is the first one listed in this matrix, we're going to say, and hence, x is equal to 2 and y is equal to 5. And that is how we solve that. All right. So we're going to look at the others in other videos. So yes, that is basically what is required. So you find the inverse in your side work, put it back in your main question, and you multiply the 2 by 2 matrix by the 2 by 1 matrix. Then you bring in the scalar and solve, and then equate the variables with the answer. And that's how we solve simultaneous equation using the matrix method.